Hello friends, welcome to today's session and welcome to Unacademy. In this session, we are going to discuss about a semaphore, why semaphore is that much needed in process synchronization. So when you talk about the semaphore, it is operating system resource as we all know. So whenever you talk about the operating system, it's completely behind the semaphore only. So why that much importance for semaphore? How it overcomes all the problems of the previous algorithms, we will see in this session. Before starting the session, let us see our anthem, Crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited and live recorded lectures from India's best educators. So, as far as myself concerned, I have got 17 years of experience in the GATE subjects and also had industry experience as a database admin and a system analyst. So, throughout my journey of GATE, I taught in many premium academies, including GATE Forum, GATE Academy, and made easy too with high success rate. So, use my referral code Sankara for admission into an academy. Please be sure that admission will give you a lot of impact in getting good set of rank. So fourth year people can opt 12-month subscription and third year people can go for 24-month subscription where you can able to get a double time recapitulation. Let's crack GATE CSE. Subscribe to Unacademy YouTube channel and hit the bell icon for the latest notification. Use my referral code for admission into Unacademy. I hope so that you all do admission into Unacademy. Let us start the lecture. So before starting lecture, I want to tell you few important points. What are the important points is what is atomic execution? Atomic execution is nothing but no preemptions are allowed. And when you talk about the non-atomic execution, preemptions are allowed. So when you talk about the race condition, two or multiple processes are trying to share the resources, common resources. Therefore, there may be a chance of inconsistency or sometimes it also leads to deadlock. So especially when you talk about the critical section, then it is having a concept of shared resource. So all your shared resources under the control of your critical section only. Now, what is a mutual exclusion? So you say that only one process is inside the critical section. So what is the spin lock? Spin lock is nothing but we are waiting for an action, but it is not going to be done. The CPU is always trying to check the condition, but it is not going to be done. Therefore, it is going to see that the wastage of CPU resources, especially in spin lock. Very, very important point. What is a spin lock and live lock? So when you talk about the starvation is nothing but waiting for a process for a long time. So when you talk about the deadlock, it is a permanent blockage. So using these definitions, we will start a concept of semaphore structure. So please be ready. Let us start semaphore structure. So what is a semaphore? A semaphore is a control variable. You can also say that it is going to control your shared resources among the concurrent processes. Hence, it is called as controlled integer variable. The integer variable you can able to access only through two atomic functions. One is a weight and the other one signal. So these two functions are atomic. You cannot able to preempt them during the execution of weight and signal operations. And as I said, the semaphore is operating system resources. The initial value of the semaphore is equal to 1. So I say semaphore yes, the initial value is equal to 1. So this is how you can say that semaphore value. And the semaphore is eligible for two process solution. But last session we discussed about only two process solution, but the semaphore is eligible for n process solution. That means at a time you can release the n particular processes which are fighting for concurrent resources, but they are going to be executed in a serial manner. without having or without violating process synchronization rule. And this was proposed by author Dijkstra, hence it is called as Dijkstra controlled variable. The always initial value is always what? One only. So I say semaphore yes, the initial value is equal to 1. So how the semaphores are going to be executed and how the semaphore is going to control over the shared resources, we will look at very carefully. Now you see, let us say what are the advantages of semaphore. So semaphore advantage is that it is a mission independent code. This is a very important point. It is a mission independent code of the microkernels. Now you see that they do not allow multiple processes to enter into critical section. Therefore, it is satisfying mutual exclusion too. It is going to provide order of the resources, order of processes to access resources, to access a shared resource. So therefore, the another advantage with semaphore is nothing but it's going to provide management of resources or order of the processes who are going to share your common resources. Now it by default satisfy progress and it is also going to satisfy blocking waiting. But you say that the bounded waiting is nothing but this is the condition. What is the condition? If I know that number of processes are prior, then I will come to know that what is my turn, I am going to get it. Therefore, by default, when you talk about the semaphore, it is going to satisfy three important properties like bounded waiting, the mutual exclusion, and progress. All the three are satisfied. Please understand, friends. So, how come this is going to execute? I will show you. Observe. And what are the disadvantages semaphore? The disadvantage of semaphore is nothing but this very biggest drawback called as priority inversion. And a semaphore is also not free from deadlock. There may be a chance of what? It is a concept of deadlocks also are there with semaphore. So how deadlocks are going to be formed in semaphore, we will look at into next session. Now, today we are going to cover priority inversion too. Priority inversion is nothing but the lower priority is going to kill higher priority process. A dangerous situation. Why dangerous situation? Why the priority inversion is there in semaphore? We will look at deep. So there are two kinds of semaphore operations. One is wait operation. This wait operation also called as a down operation, also called as a P operation. What is a P and what is a V? I will show you. And the other kind of operations are called the opposite to wait operation is nothing but signal operation, and the opposite to down operation is nothing but up operation. The opposite to P is nothing but V operation. So V is also called as release operation. So what wait is going to do, what a signal is going to do, we will see now. Before that, you observe these important points. What is that? So there are two kinds of operations are there on semaphore, down and up. So down is called as a wait, also called as a P. P is nothing but probir and it is called as a what? Release. And up operation is nothing but what? A signal. It's called as what? Verhoop, also called as a P. But you need to see that how they are going to use the semaphore is you always use first wait function. This is the mandatory, and you always use to you have the concept of signal function. This is why these two supposed to be used in order in the sense you want to use effective proper synchronization, then better you use always down first followed by signal. So this is the concept. Now you see what is a wait operation and what is a signal operation, we will see in its code. But you please see that these two operations, that is a down and up operation, they are purely atomic nature. So what is atomic nature? You please understand carefully. You cannot do any kind of preemption during execution of wait and execution of signal operations. This is a mandatory condition or assumption. Now you see, this is your semaphore structure. Now I'm providing two kinds of semaphore structure. One structure is with busy waiting and the other structure is without busy waiting. So first let us understand what is with busy waiting structure. Now you see, this is your wait function. So wait function is saying two statements, statement number 1 and statement number 2. What is the statement number 1? While s less than is equal to 0, then trap, otherwise do skip, otherwise no action. So whatever you want to say, you can say that. All are synonyms only. No action. It is going to be under a loop. And immediately the second statement is because wait operation is going to decrement the value. So by default decrement is a -1. Therefore s dot value is equal to s dot value -1. And what is the concept of signal? The signal function is nothing but it is trying to do what I mean to say, incremental operation. This is called increment. This is called a decrement operation. Okay, friends. So how it is going to provide a proper process synchronization by satisfying mutual exclusion, progress, and bounded waiting, we will see now. Please observe, friends. When I am talking about a wait function, before you want to access your critical section, then after that you release this. So signal function. This time your critical section is being protected using, this is your shared resources which consist, this is going to be protected using wait function and signal function. This is the mandatory. So what is a wait and what is the signal, we'll see now. So when you talk about wait function, this is called as decrement function. Also we can call it as decremental operation. So when you call signal, and a signal mainly what? For incremental purpose. How this is going to be done? Let me explain through an example. I say semaphore by name S, the initial value is equal to 1. When I am saying semaphore S initial value is equal to 1, this is being accessing by, let us say, two process by name P1 and by name P2. Both are trying to access this semaphore in order to share a common resource. This is important. So they want to access a common resource. That's why they are going for semaphore concept in order to prove all the three properties: mutual exclusion, progress, and bounded waiting. Now you observe carefully. When I call P1, I want to access this common resource. So this common resource, I'm going to keep it in critical section. And this common resource, I'm going to keep it in critical section. Now this critical section must be provided using two important functions, that is wait on S, and here also he is going to call wait on S, and wait S is nothing but a semaphore variable we are going to use. The default variable of your semaphore is equal to 1. Why 1? We will learn in this session slowly. Then after the using your semaphore, then you supposed to use signal after accessing your critical section. Now here also after accessing your critical section, you better you give the semaphore just a signal I am giving. Now you observe carefully here. So this critical section is protected. This critical section is protected using like this. So when a process 1 calls wait function, please understand, when a process 1 calls wait function, we know the wait operation. What is the wait operation? Wait operation is going to check first of all whether your s dot value lesser than is equal to or not. So as far as given example concerned, I say that S is equal to 1. It is not lesser than is equal to 0. Therefore, you are breaking a while loop and enter to access the second line. What is the second line? S dot value is equal to S dot value minus 1. Therefore, what has happened, friends? Observe carefully. I am coming with S is equal to 1. I checked when you call weight, please understand, when you call weight, it itself calls the weight structure. What is a weight structure? Just now I shown you. This is your weight function. What is your weight function? Please understand. As soon as you call there, I called as a weight semaphore yes, then what is going to happen? It called your weight structure. The weight structure first of all cross check while condition that your S dot value is lesser than is equal to 0 or not. If it is satisfied, then do skip. Otherwise, you decrement the operation successfully. S dot value is equal to S dot value minus. So as far as the given example concerned, the semaphore value is coming with S is equal to 1. So it come here and it checks 1 is not lesser than is equal to 0. Therefore condition becomes false and it reduces the S value successfully to minus 1. Therefore what is going to happen, friends? Here only I am doing. You are coming with initially 1. Your weight condition satisfied. Then it sets the value to what? 0. So when it becomes like this, then you're successfully down the operation, then you enter into what? Critical section. As soon as you enter into critical section, access your all your shared resources which are there in your critical section, then you give a chance to others. Otherwise, it is going to be unbounded waiting. Therefore, we know the concept of how you can able to protect your shared resource using two important statements we learned earlier, lock and unlock. If you not do this lock, after that unlock, if you not do, then what is going to happen? Other processes are going to be under starvation. That's why once after you completion of your resource, immediately you release the particular semaphore so other guy can able to successfully down it. Therefore, when I am saying a signal operation, what is a signal operation? We know that signal operation is nothing but incremental operation. So as soon as you call the signal operation is there, then control will come here. Then I say that signal semaphore yes. Your C, and it is nothing but there is no condition at all, simply a formula, increment operation S dot value is equal to S dot value plus 1. That's therefore what happened? Earlier you made from 1 to 0, this time you made from 0 to 1. Please understand carefully. Earlier you made 1 to 0, the signal operation is going to put 0 to 1. So you are sending a 0 value to here. After doing updation, then it is going to be what? Again it went to your starting value, that is equal to. So using this kind of sum, what I mean to say, mixing operations of your weight and signal, how you could able to achieve process synchronization, we will see with one example. So any doubt you can please post. Now I am saying that there are 2 or 3 processes are coming. I say semaphore S is equal to 1. There is a process 0 and there is a process 1 who are trying to acquire shared resources, and that shared resources is under protection, and that protection is going to be, that means what, a process can able to enter to access your critical section. There is a first wait operation, then signal operation. So you people are getting doubt that why I am starting with the wait, why can't I am starting with the signal? Naturally you people get a doubt. I will tell you why. Just wait for 1 minute. So I say that S is equal to 1, and which is under, it is also operating system resource which is under sharing. Therefore this S is equal to 1 is going to be accessing by P0 as well as P1. Now you observe carefully. As soon as I call wait function, we know that already we have seen in the earlier example, I am coming with a 1. So 1 becomes what? Decrement operation, that is 0. So therefore once you are successfully making a down operation, Successfully making a down operation is nothing but the while condition is satisfied of your wait function. Please understand. What is your while condition? Please see. While condition is nothing but if your s dot value is lesser than is equal to 0, then you are going to be under trap. You cannot decrement it. But here my s value is greater than 0. Therefore, I am not in a trap. So I am able to enter into second statement. Therefore, my minus operation is going to be done. Therefore, in that case, what will happen? You are successfully decremented from 1 to 0. Now I am accessing your critical section, then you are going to release it. So you are sending a 0 from there. Now what the signal operation is going to do? It is going to do increment, that is nothing but plus 1 as far as the structure concerned. This time the control will come here. So you are sending a value, the semaphore value as a 1. Now 1 will come here. He also called wait function. It is going to check the while condition. What is that? Your semaphore value is lesser than is equal to 0 or not, but your semaphore value is greater than 0. Therefore, you enter into second statement. That means what? You could able to do decrement operation. So after that critical section, then you send this 0 here and the 0 can be all incremented to 1. So I can say that how they are executed in order to access your shared resource P0 first and P1 second as far as this example concerned. Now you observe carefully one important thing. I say, all of you, please be observe friends. So evening you all supposed to do problematic on Unacademy student learning app. Those who are on live, if you not yet downloaded Unacademy student learning app, immediately download. Today you are going to solve very good problems on semaphore. So once you are confident in proving semaphore, it will be 100% all right on process synchronization. 70% of the questions you are going to get from process synchronization only from semaphore only. Not only 70, 90% you can take from semaphore. So 2 to 4 marks you will get. So observe carefully. Let I'm coming semaphore value to 0. When you are saying semaphore value 0 and this is been accessing by process P1 and process P2. Observe friends. And one more process is also there, that is process 3. For all the process, the structure is same. What is the structure? Wait function is same, signal function is same as I shown you the structure. Now, in order to access any kind of your shared resources, which is going to keep under your critical section. So your critical section is supposed to be protected. How are you going to protect it? I am saying this time wait of yes. So I'm saying weight of yes. When you say weight of yes, please understand. When you say weight of yes, then what is going to happen? It takes you to while. That means what? Weight operation. What is your weight operation, friends? Observe carefully. Please understand. I'm coming with s is equal to 0. Then process P1 called weight function. As soon as you called weight function with s is equal to 0, the weight function is going to be executed like this. While s dot value lesser than is equal to 0, if it is satisfied, you are under trap. Therefore, what is going to happen? As you are coming with s is equal to 0, I am trying to do that s dot value lesser than is equal to 0 or not. Yes, as I am coming with s dot 0, then you are going to be under what? Loop, or you can also say that do nothing, or you can also see that no action, or you can also say that it's a trap. That means you cannot enter into decrement operation now. So what I am telling, I want to do s is equal to s minus 1, but this is not possible. Why this is not possible? Because you're waiting to satisfy this condition. That's why you cannot start your semaphore value with the what? 0. The minimum semaphore value is supposed to be what? 1 in order to use a wait, then after that signal operation. Don't forget that. But I will give you different examples. Don't worry. So as far as s is equal to 0, what has happened? So this is unsuccessful, right? This wait is unsuccess. So you are going to under wait. And even you call once again weight of yes, it is also unsuccess. When it is unsuccess, you are going to be once again under weight. It is also, when I call weight function here, weight of yes, it is also unsuccess. You are going to weight. That's why you don't start your value with less negative, or you can say that 0. Your value is a minimum 1 in order to use your semaphore effectively. So let me take this time different value. I say let s is equal to 0. Please all of you observe carefully. Let s is equal to 0. I am taking p1 and I am taking p2. All of you observe. So instead of weight, I am starting this time with signal. Please understand. Please understand all of you. These are the different questions I am going to provide in the evening session. I say signal of yes. Then I say weight of yes. Then I say critical section. Then I say once again signal of yes. You can use whichever way you want, no problem. Now what has happened? Now your success. Why your success? You are coming with s is equal to 0. Therefore, what is going to happen? Signal of yes. What is the signal of yes? Without having any condition, simply it updates. Therefore, what happened? This 0 becomes 1. So when this 0 becomes 1, as this is a global variable semaphore, so 1 becomes 0 and you entered into what critical section, then 0 becomes what? 1. You can also make use of semaphore like this. Please don't forget this. So just you learn how they are going to be operated, and remaining all you will come to know. Now we made one time unsuccess with 0. We made one time success as long as you are having a different signals and weight operation. But as far as my advice concerned, you always start initially weight S and signal S for effective use of your semaphore. This is the rule. Please follow. As far as rule of semaphore concern, if there are any kind of preemption, then you are going to be under worry by taking a signal weight and signal. Better you follow first of all, acquire the semaphore and acquire the critical section, then you release your semaphore. This is the concept. So some people are asking question like this from the audience. So already I started with the 1, it's got completed. I started with 0, I also shown you. If I am saying the 2, what will happen? Now I am coming with a positive value. If I am starting with 2, what will happen? Or 3 or 4 or 5, what will happen? Let us see now. When I am saying 2 here, so now process 1 and process 2, they are playing a crucial role here. Now I said that for any kind of effective utilization of your semaphore, you please use weight S, then you use afterwards signal S. You will come to know by doing solving problem why I am trying to tell you to use in this way only. So as usually, I started weight of yes. All of you please understand. And this is your critical section. And I am saying signal of yes. All of you observe. Now this will be success or not. Whether P1 can able to access your critical section or not. Or whether P1 can able to do successful down or not. We will see. Successful down is nothing but he is going to do decrement operation successfully. Later I will tell you differentiate what is success and unsuccess after some time, but you understand here carefully. Unsuccess means you cannot able to do decrement. Success means you can able to do what? Decrement. Now I'm saying once again here, this time he is coming into the picture and trying to access CS, and I'm saying here signal off here. Now understand friends what will happen. See this? S is equal to 2 I am coming. So when you call weight function, you are coming with 2. Your 2 is not lesser than is equal to 0. Therefore, you can able to do decrement. So 2 becomes 1, obviously. So critical section. Now see, after doing that, your S value, if I am using here, what is S value or 1 I am using. Therefore, see that this side is checking the condition. What is that? 1 not less than 0. Therefore, what he is going to decrement successfully. So he is also what? 0 only. Therefore, what will happen? The P1 accessing critical section P2 also accessing critical section. So when multiple processes are inside the critical section, then it is a concept of what? Now P1 as well as P2 both are in critical section only. So in this case, we can confirm it is not satisfying mutual exclusion, because mutual exclusion as per as process synchronization concern, only one process can able to access your critical section carefully. But if I am taking greater than 1, please observe why to take 1, why not to take 2. That is the ambiguity we are. If I am starting with greater than 1, then those many processes can able to enter into what? Critical section. So if I am saying, friends, final example to you, if I am saying SC is equal to something like 10, what is the meaning of that? I can say that 10 processes 10 processes can allow to access critical section. Therefore, I can say that in this no mutual exclusion. If I am saying one more example, friends, all of you observe carefully. I say S is equal to 1. Now you all can tell me how many processes can be accessed critical section at a time. Please give a comment. How many processes can access critical section at a time? Please all of you comment, those who know. So your answer, waiting for your answer. What is your answer? How many processes can be allowed inside the critical section? Anybody please respond. With this semaphore value, how many processes can be allowed to access into the critical section? So what is our answer? 1, 2, 3, 4 or multiple. So you can say that it's as you are saying that 1, then I can say that what? You can able to access what? Only one process at a time, because now I will show you the difference. When I am saying a P1, when I am saying P2, I am coming with a one value semaphore. Now as soon as I say, please understand, as soon as I say weight of yes, then what will happen? As I am calling first time weight function, P1 call weight function first time. Therefore, what happened? He is successful because 1 not less than is equal to 0. So this 1 becomes 0 here. Now, as soon as he is a success, he is now inside the critical section. Step number 2. If I give a control here, now P2 give a control here. As soon as P2 preempts P1, then what is going to happen? This value is sharing there. What is the latest value? 0 after decrementing. So you got 0 here. Now I'm going to do here weight of yes. I said that while condition. What is the while condition? 0 is lesser than is equal to 0. Yes, obviously this condition is true. When this condition is true, then you're going to be under what? Weight. Therefore, this is how you can able to block other process not to access critical section. Only one process can be allowed into access what? Critical section. Therefore, using this number, you can designate that how many process I can able to allow you to critical section or not. Now, is it clear, all of you friends? Is it clear, all of you? Now I say, for example, S is equal to 1, I am coming, and this is being done by 3 different processes, P1 and P2 and P3. Now I am saying, please understand carefully. I am saying as usually, weight of yes. He is also doing weight of yes. He is also doing weight of yes. Now you understand. Critical section. Here also critical section. Here also critical section. Observe that I am coming with S is equal to 1. After your critical section, you need to release it. Signal of yes and signal of yes and signal of yes. Now you tell me, I will give you some kind of assumptions. Line number 1, first step, P3 begins. So when P3 begins, he receives this value. So this value is a 1. 1 is becomes 0, because you please understand, friends. Please you understand carefully. When I am talking a weight of yes, then you are going to call weight function. Please understand what is a weight function. All of you observe carefully. What is your weight function? Your weight function is this. What is that? While s dot value lesser than is equal to 0, do skip. Then after that, s dot value is equal to s dot value minus 1. So you people may feel that I can able to do preemption during execution of your what? I can able to do preemption during execution of your weight function, but it's not possible. You see that the weight function has got two statements. One statement is while s dot value lesser than is equal to 0. This is a one statement. Then after that I am saying s is equal to s minus 1. This is a second statement. Don't think that they are the two different statements, because while statement is atomic, that means what, your weight statement is atomic. No preemptions allowed in between. Therefore, I cannot give any kind of preemption between. They are being sealed. Sealed means what? Either you can give preemption before while, or you can give preemption after yes, but between the while and yes, you cannot able to do any preemption. Please observe. Now here what is happening? As soon as I called wait, other process must wait till I execute while as well as decrement operation. As I am saying that 1 is not lesser than is equal to 0, I am out of the loop, then I can able to do what? 1 becomes what? 0. I am success now. As soon as you success, second statement. So P3 begins and executed wait as 1 becomes 0. This is done. At line number 2, P2 preempts, please understand, P2 preempts P3. So when P2 preempts P3, what is going to happen? He is also called wait. So when he call wait, this is a common wait signal, wait signal, wait signal. Every process has to use this. When P2 call wait yes, now the operating system is going to send the value 0 here, because already 1 is become 0 there after doing a decremental operation. When I am saying 0 here, now the process 2, the condition is going to be satisfied. So you are under trap. What is the meaning of that? 0 lesser than is equal to 0. Yes, it is a true. So when it is a true, you cannot able to execute minus operation. Therefore, here what happened? When you say wait of yes, then you are going to be under what? Waiting here. Please observe how this is blocking other process not to access your critical section. Statement number 3, please understand. Statement number 3, P1 also same. P1 also executing in the same way. P1 will get a, what is the value? 0 only. Then he cannot able to do anything. Therefore, this condition is a true. When while condition is a true, then P1 is also going to be under what? Waiting. So what do we understand? Whoever starts first, he will get the access onto your critical section. Therefore, what is the order of the execution here? The order of the execution here is first P3 will execute, then after that P2 will be removed from the waiting, then after that P1 will be removed from the waiting. Then what do we understand? You are seeing a serial execution such that P3 followed by P2 followed by P1, because soon after completion of the P3, then your 0 becomes what? 1. So when 0 becomes 1, this 1 will pass over there. Now your condition becomes a false. Now you can able to enter into critical section. That means 1 becomes 0. Again you say that signal of yes, then 0 becomes 1, and this value go back there. Now this condition is a false. Now 1 becomes 0 there, and after that 0 becomes what? 1 there. This is how they are being exchanging the semaphore values 0 or 1 from each other. Now you understand, friends. So now let me tell you. So finally, you all please reply to my question. If I am saying that SC is equal to 3, if I am saying that SC is equal to 1, if I am saying, what is the meaning of SC is equal to 3? How many processes I can put in the critical section? You know. How many processes you can put in the critical section? Tell me, friends. So with SC is equal to 3, how many processes I can able to put in the critical section? Yeah. So we can say that three process inside, and we say that one process inside. If I'm saying that S is equal to 0, please respond. S is equal to 0, how many process I can? S is equal to 0, how many process I can? When I'm saying that semaphore S is equal to 0, how many process I can? Please respond. If I'm saying that S is equal to 0, so how many process I can? Yes, no process. None of the process. None of the process can be inside the critical section because your wait operation is going to be unsuccess. Your wait operation is going to be success only the greater one only. When you say that greater than 0, then your wait operation is successful. Otherwise, your wait operation is blocking that particular process whenever you are coming with a 0 or a negative value. So this is about the sample structure of semaphore. I hope so you cleared. So how it is going to restrict other process not to allow into critical section. Now I'm saying, please understand carefully friends. Now I'm saying like this, let I say S is equal to 1. Therefore P1 and P2, two processes are there. Please understand carefully. So I say weight of yes. He is also coming with weight of yes. Then he is trying to access critical section. He is trying to access critical section. Whoever begins first, he will get the chance. We know. So if I am saying that first one, so I'm saying that next after weight function we have a signal. Signal also I can write as V of S. This I can write as a P of S, no doubt. So P of S or weight function. Now what will happen? Let P1 begins. When P1 begins, so therefore this 1 becomes 0. If you give preemption, no use. Please understand. That's how it is telling you that only one process can be allowed inside the critical section. After making this 0, then other process, even you give the preemption, it is not possible. He is going to be under what? Waiting only. You can test yourself after some time. So any number of processes, whoever is preempted there after wait function, no use. Before wait, okay, that process can be allowed. After wait, it is not possible at all. So please be remember. That's why whenever one process begins and successful in the wait operation, then all other process must be under wait because your condition is in such a way that you are going to stop there. Okay. Now you observe friends. So what are the applications of your semaphore? Applications of your semaphore are nothing but what? It provides only one process to allowed into critical section. Don't guess that we are going to take greater than 1. The default minimum value is always 1 in order to effective utilization of your semaphore. So it provides order of execution, serial. Order of execution is nothing but serial execution, one after another it is going to provide. So it is useful in resource manager. Why we say that resource manager, there may be a chance of what shareable resources. When you talk about the shareable resources, then we need to provide a what? Order. This order is going to be done by semaphore only. Now let us see the example of semaphore. So the example of semaphore is like this. So process P1 called wait and signal in order to access critical section. Please understand the process P1 first resume wait, then critical section, then signal. Remaining we don't mind time waste. Now you see, as soon as you call wait, please observe friends. As soon as you call wait, what has happened? This wait will call this function. So please observe again. I am telling you, I am giving you revision how the wait function is going to be executed. So as soon as you call wait, this function is called for, and you see that what is your value. If I am saying that something like s is equal to 1, therefore what happened? This you are sending a 1 value there. So s is equal to 1 I am sending. So while s less than is equal to 0, 1 is not less than is equal to 0, the condition becomes a false. When condition becomes false, you are making a successful down operation. S is equal to s minus 1. Therefore, 1 becomes 0. After that, I am calling a signal function. Signal function is nothing but signal of yes. So you are sending what is the value? Signal of 0. Signal function is also called as a v function. When I say v of 0, then it calls a signal function over there, and it is saying that s is equal to s plus 1. So therefore, this 0 becomes 1. So this is how the operations of your semaphore. So please be understand, during wait execution, during signal execution, preemptions are not allowed as they are atomic function. Before wait or after signal, your wish. Please understand carefully. Now next example, see that. I'm coming, s is equal to 1. So I'm coming, s is equal to 1. If I start P1 first, so P1 executed P of A. Here P is nothing but, don't understand, don't get confused. P is nothing but what? Wait only. Please understand. P is nothing but a wait. Now when I say P here, so when I say P of A here, that means what? Your semaphore is not S here. Your semaphore is 8. That is A. Now what is going to happen? Your 1 becomes 0. Therefore, because wait operation is going to do the successful decrement operation whenever your S dot value is greater than 0. So now, if any process gives a preemption, so there are two preemptions have come. One is from P2, one is from P3. You are sending a 0 to them. Please understand. You are sending 0 to them because already you are successful down operation. Therefore, what happened? This receives 0, which is lesser than is equal to 0. Condition is true, and so this process is supposed to be under wait. Now it also receives 0. 0 is lesser than is equal to 0. Therefore, it is also going to be under what? Wait only. How long they are waiting? This is very, very important. How long they are waiting? How long? P2 comma P3 are in wait. Are in wait means question mark. So as soon as P1 gives, please understand, as soon as P1 gives which function? Signal operation. Therefore, 0 becomes 1. When 0 becomes 1, this condition is a failed and this condition is a failed. Therefore, you are successfully enter into critical section. So as soon as the P1 releases what? Signal of yes. Because the signal of yes 0 becomes 1, therefore other can able to use it. Now come to the next point. Now please see friends. There are two processes, process P and process Q. So here mutual exclusion, mutex stands for mutual exclusion. I am saying 1. By default value mutex is 1 only, mutual exclusion. Now you see wait mutex. All of you please respond through comments. When I say wait mutex, first process, when I say wait mutex, then 1 becomes 0. If we say wait mutex as a first time, then he also is going to be 1 becomes 0. So using that scenario, he is asking you to do what? Please understand. If process P and Q execute parallelly, then what is the generated string by the above? So who decides which process to enter into critical section? That depends upon the request. That depends upon request. First come, first serve, or priority. Please understand carefully. Or priority. First come, first serve, or priority. Based on your hit, it decides. So I'm telling you here, this is the assumption to you. What is the assumption? If P and Q executed parallelly, then what is the generated output? What is the generated output? Please see here. So if I'm calling a print 1, if I'm calling a print 0, so continuously can I able to do or not? Now I want to give one example here. So I say let semaphore is equal to 1 and there is a process P naught. I say wait of yes. Please understand friends. Print 0, when I am saying signal of yes. Okay, all of you please observe carefully. Now only one process is there. Observe, I am taking only P naught so that better understanding to you. Now you see. So this S is equal to 1. 1 becomes 0. As soon as 1 becomes 0, I can able to print your output what? 0. Then after that next step go to signal of yes. What is the signal of yes? Your 0 becomes 1. So therefore, only one process is allowed into the critical section. My question is, can I repeat this? Can I repeat this? Please all of you tell me. Can I repeat this? So after printing first output statement that is 0, can I repeat this once again? So can I repeat this? So first iteration completed, please see. After first iteration, I got 0 output. Now can I do second iteration with the same structure? Can I do second iteration for the same structure? Please observe carefully. So after doing signal operation, your 0 becomes what? 1. So again I am trying to execute. Please see. I am going back. When you go back, your S value becomes 1 now. Again, once again it is reset to 1. Therefore what happened? Again it is doing 1 becomes 0. Therefore again I am printing 0 here. Then after that 0 becomes here after executing signal. Now again if I am executing once again, is it possible or not? Please understand. Is it possible one more time or not? Yes. Again I am setting a S value to how much? 1. Again I can do what? 1 becomes 0. Please understand. Again I can do successful decrement. 1 becomes 0. And here also 1 becomes 0. So after third iteration, please understand. After third iteration, then what is happened? It prints 0. So what is your final output? Your final output is it keep on generating zeros. It keep on generating zeros. Therefore, you say that it is a what? 0 star. What is a 0 star? I can able to print n number of stars, n number of zeros because it is satisfying a property. Which property? When I am keep on entering into critical section continuously, when others are not interested to access critical section, it is a progress. Therefore, it is satisfying progress as well as it is satisfying mutual exclusion too. Therefore, finally, your answer in this is a what? 0 star. Clear, all of you? Now you observe the previous question. All of you, please look at the previous question. So I'm saying like this. So your mutex value is equal to 1. So your mutex value is equal to 1. Therefore, what happened? I'm saying that your P and Q can execute parallelly. When I'm saying P and Q can execute parallelly, then what will happen? P thread can execute parallelly, Q thread can execute parallelly. Then what will happen? Let us see. Please all of you understand carefully. If I execute process P, Q cannot execute. Please understand. When I am executing process P, and P cannot be executed because it cannot able to make a successful decrement operation. Therefore, what will happen? Either P can execute at least once, or Q can execute when P is not able to access your critical section. So in that case, PQ cannot run parallelly. Either you can run P or you can run Q, because we know when we say that the mutex value is equal to 1, only one process can be allowed to access critical section once. Either P can execute or Q can execute. Please see. If P itself is continuously execute, then what is your answer? Please tell me. If P itself is continuously execute when Q is not interested to execute, what is the output you are going to get? You are going to get what? Once. If, please understand, if you say that if Q, the P is not inside now, the Q, P is outside now, if Q is continuously doing this kind of number of iteration, because I got 1, then 0, so I am printing 0. Now signal means 0 becomes 1. So again it is going back. Every process can go back with the semaphore. That's the beauty of this. Again I am doing 1 becomes 0. So I am printing 0. Next 1 becomes 0. Again I am going back. So I am printing continuous zeros. So what is your output? Either you do 1 star or you do 0 star. So this is your answer. So in order to print this kind of input from this kind of code, piece of code, then the output generated is what? Either 1 star or 0 star. Any doubt? Tell me, friends. Come to next example. Yeah, so here, so it is not option A. Please understand, friends, it is not option A. Option A means 1 1 1 followed by 0 0 0. That's the meaning of option A. Concatenation 1 followed by 0. That is option A. But option D is different. What is option D? Either ones or zeros. Please understand carefully. There is a difference between option A and option D. Option A is nothing but what? 1 followed by zeros. So, but option D is either ones or zeros we will print. Both at a time is not possible to print. It is not the concept that I will print 1 0 1 0 1 0. It's not at all possible. Why it is not at all possible? Because only one process is allowed inside critical section. Either you can print at a time once or you can print what? 0. So if you use one time P and one time Q, your answer is 1 or 0. Please understand. If you call P for one time, then it will print 1. If you call Q for one time, then it will print 0. So what is your output? Either 1 or 0 it will print. Both it is not going to print. Please understand. Clear? So come to next example. So this is your next example. So finally, we understand that it is satisfying mutual exclusion. It also satisfies progress. Because mutual exclusion means as long as your S is equal to 1, only one process I can able to put in the critical section. And progress means what? When other processes are not interested to access critical section, myself would like to go n number of repetition, then it is possible. So you can go n number of repetition. Therefore, it is a